So in this problem, we're given a cylinder that's rolling down a ramp that is released from rest without slipping, and we are asked to find the initial angular acceleration and the time required for the cylinder to roll 5 meters. So a good first step is to draw a free body diagram of this cylinder. So we have, it's just going to be a circle, and we're going to put our y direction, we're going to make it so we don't have to do too many conversions with theta, which is going to be 20. So we're going to put y in that direction, x in this, because this is the way that it's rolling. So we first have our acceleration in the x direction, and then we also have our force of gravity, which is acting straight down on the center of this cylinder. And we have our theta value right here. Since this is 20, we do a little bit of geometry and we find that this angle in between our force of gravity and the y-axis is going to be 20 degrees. And then we also have force due to friction, and we have a normal force on the cylinder as well. And then finally we have our angular acceleration of this cylinder. So our knowns, what we know is that we have a radius of 0.15 meters. The mass is 10 kilograms. It's initially, the initial is 0, so it's at rest, and we have our theta value is 20 degrees. So now that we have this, we can start to do our equilibrium equations. So we have our forces in the x direction, which is equal to mass times acceleration x, which is equal to 10 times acceleration x, because we don't have the acceleration in the x direction, which is equal to our the x component of our force of gravity. So force of gravity is gravity times mass, so acceleration due to gravity times mass, and then for the gravity in the x direction, that's going to be, we're going to multiply this by sine of 20, because that's going to be what gives us our x component. If you're looking at this, sine of the force of gravity is going to be the x component going this way, and that's going to be minus the force of friction, because force of friction is acting negatively. So now we have forces in the x directions. We're going to do the net sum of moments acting on the center of the cylinder. So we have a moment due to the force of friction. So a moment due to the force of friction is going to be the force times the radius. So negative force of friction times the radius, 0.15, and this is equal to I times angular acceleration, which is equal to 1/2 times 10 times 0.15 squared. This is our I value, and multiply that by angular acceleration. So we have our sum of forces in the x direction, and then our net moments acting on the center of the cylinder. So from here we want to get, so we have the term of acceleration in the x direction, and we have our angular acceleration, and we want the angular acceleration. So we're gonna put a in terms of angular acceleration. So since this cylinder is rolling without slipping, we know that acceleration in the x direction is equal to negative r times angular acceleration. And this simplifies to ax is equal to negative 0.15 times angular acceleration. And then we can plug this. So we have the information that we want. We have our equilibrium equations, and we have AX in terms of angular acceleration. So what we're going to do next is plug that in. So when we're plugging in to our sum of net forces in the x direction, we're plugging into that, we get 10 times negative 0.15 angular acceleration, and that's from this value here, is equal to 33.55, which is just this solved, it's this simplified, minus force of friction. And so when we solve for this, we can get force of friction is equal to 33.55 plus 1.5 times the angular acceleration. The 1.5 is just this simplified, and we moved this over, or we moved this over and then moved the force of friction over as well. So then we can also plug, we can also simplify our sum of the moments equation. We can simplify that to negative 33.55 plus 1.5 times angular acceleration, because we have, up here we had our moment equation up here is the negative force of friction times 0.15. So this is the negative force of friction, and then multiply this by 0.15, which is equal to 0.1125 times angular acceleration, and that is this value simplified. And then when we solve for that, when we go through and simplify these terms, we get negative 5.0328 is equal to 0.3375 times angular acceleration. And we can solve for angular acceleration, and we get our angular acceleration is equal to negative 14.91 radians per second. So we can plug our angular acceleration back into a of x is equal to negative r times angular acceleration, and this gives us a negative 0.15 times negative 14.91, and we get acceleration x in the x direction is equal to 2.24 meters per second squared. And then from here we can use our kinematics equations to find out the time it takes for the cylinder to roll 5 meters. So our distance traveled, or our x, is 5 meters. Velocity initial is 0 meters per second. We know our acceleration in the x direction is 2.24, and we want to solve for time. So we can we have a kinematics equation, which is x of t is equal to 1/2 acceleration times time squared, because our velocity initial is 0. And we can plug in these values. 5 is equal to 1/2 times 2.24 times t squared. And this gives us that our time it takes to roll 5 meters is 2.11 seconds. So these are our answers. This is our initial angular acceleration, and this is our time it takes to roll 5 meters.